blood gets rerouted to the heart and the skeletal muscle. Heart rate goes up. Breathing rate goes up. We get bronchodilation, which means the airway gets bigger so you can get more air in and more oxygen in. More oxygen you can get to the muscles, the more your muscles can do, the faster you can get away from the tiger. But there's an interesting sort of psychological phenomenon here with the sympathetic nervous system now. So back in the day, like, this was a legit fight or flight thing, right? You walk outside and there's a dinosaur or whatever, and you gotta run. And it's obviously not a dinosaur, but Jurassic Park. My kids have been watching Jurassic Park. It's just kind of right there. So, fight or flight. It's gonna save you. Which of those is selected for, incidentally? Which of those is gonna allow you to survive the situation? Fight or flight? Flight. You're much better suited running away than you are trying to fight. It's a bear. What are you going to do, punch it? The snake, right? The rattlesnake, you're not going to punch it in the face. Well, snakes ain't going to tolerate that crap. So yeah, flight is really kind of a selected for thing. The thing is now, is that fight or flight still occurs in stressful situations. But stressful situations now are not what stressful situations used to be. Stressful situations used to be, right, a tiger or whatever. Now it's like, you have an exam that day. Fight or flight. But what makes sense now? Like, running away? No. Punching the test? No. They're not going to help you out. So neither one of those makes sense, and what happens is you freeze. Because your brain's like, fight or flight? Nothing. I've had people turn in blank lab exams. People I know for a fact should know that information. Like, they've stayed here, they've studied, they've been over it, they know it, and they give me a blank piece of paper back, and they're like, I just froze up, I can't remember anything. Deer in headlights. Constricted pupils, sweating. You can tell they're stressed out. Or they're on meth, whatever. Blank piece of paper. You see public speaking, same thing. Like, people get up there and they'll freeze like a deer in headlights because they just freak out. And that fight or flight kicks in, but it doesn't work there. Neither fight or flight work. So you freeze now. And we get a lot of that, where people just kind of freeze up. The fight or flight response, still, it's kicked in stressful situations. Now, we're doing this, and this is going to be based on the release of neurotransmitters. So let's look at how these two branches work with different neurotransmitters to perform these tasks. All right, so if we're looking at the parasympathetic branch, in the autonomic nervous system, once you leave the spinal cord, there are two neurons that will connect to the autonomic nervous system in a chain, in a relay. So what we see is the first neuron is called the preganglionic neuron. And the cell body for this neuron begins at the brainstem with cranial nerve 10, the vagus nerve. And the axon's really long, and it stretches out to, say, right beside the heart. And then we have another neuron in the chain here, which is going to send us at our target tissue. This is the postganglionic. Sometimes this is called the ganglionic neuron. This first neuron in the chain, the preganglionic neuron for parasympathetic, is longer than the second neuron, and it's lightly myelinated. I'm going to move that arrow because it's going to help me out later. So it has the myelin sheath, but not a whole lot of it. The second neuron in the chain is unmyelinated. we have neurotransmitters that are released. Here at this is called the ganglionic synapse. At the ganglionic synapse, our neurotransmitter is acetylcholine. Here, at the target synapse, the neurotransmitter is still acetylcholine. So for the parasympathetic nervous system, the only neurotransmitter in play is acetylcholine. Now the sympathetic branch is a bit different. We have this sympathetic trunk that runs all the way down the spine, right beside the vertebrae. So that first neuron in the chain, the preganglionic neuron, is shorter. It's still lightly myelinated. It's just shorter. The next neuron, the ganglionic neuron, will be longer. And it's also unmyelinated. The neurotransmitter here at the ganglionic synapse is acetylcholine. The target over here. At the target synapse, the neurotransmitter is norepinephrine. We also have a special case of the sympathetic nervous system. The sympathetic branch has a direct electrical connection to the adrenal gland. Either adrenal gland, either side. Still a lightly myelinated axon here. No synapse there, it's an electrical synapse. The adrenal gland puts out epinephrine into the blood as a hormone. And this is one of the major differences between the parasympathetic branch and the sympathetic branch. The parasympathetic effect, this rest and digest, feed and breed, it's based on acetylcholine. And remember, we talked about how acetylcholine leaves the synapse. There's an enzyme that's always breaking it down. So parasympathetic effects are really short. All that has to happen for parasympathetic to stop is you stop releasing acetylcholine. All right, we're done. Like, it's gone immediately. So it's extremely short-lived effect. The sympathetic thing, that's going to take a lot longer because if we just dumped epinephrine into the blood, so to get epinephrine out of the blood, your liver has to get rid of it, and your kidneys have to get rid of it, and that's a breakdown, and it takes a long time. So like when you go ride the roller coaster, so you ride like the world's largest roller coaster, you're going to die, you're going to die, you're going to die, you get off of it, your heart's still beating 100 miles an hour when you get off of it. It's not like it just stops and you're like, oh, I'm glad to be off that, and I'm going to sleep. It doesn't work like that. Like your heart's still going 100 miles an hour and you're still going on that sympathetic rush there, the fight or flight. It takes a while for those effects to wear off. Right? I could throw the rattlesnake out in the middle of the room and you'd freak out and you'd scream and I'm like, no, it's just a toy, and I pick it up and your heart would still be beating like 100 miles an hour 30 minutes from now. You'd be thinking about that time I threw a fake rattlesnake out. Actually, I could do this with like just a really tiny spider and I'd get at least half of you. Pick a little tiny spider, toss it out, people scream.
You used to not be afraid of spiders.
It's crazy. I've had people like actually jump up in class because this stupid building's got spiders in it. They're not mine. I did not do it. But like just spiders will crawl across it. I'll see people jump up and like, what's wrong? It's a spider. I'll here, pick it up, put it in my pocket or something, just for laughs. That always gets like freaks people out. They're like, what's going to happen to it? I'm like, it's fine. I'll just save it for later. All right. Sympathetic effects, longer lived than parasympathetic effects because we've got epinephrine coming out here in the blood. All right. So now, this is the autonomic nervous system, visceral motor. Somatic motor is not part of the autonomic nervous system. Somatic motor, we just have one neuron in this chain. and it's going to end up at muscles.